Okay guys, in this video I'm going to share with you the workflow that I do to create meshes in OpenFOAM. In this case we're going to create a 2D mesh, and we're going to use this report as the geometry we're trying to replicate. So this is a report from 2012, but I found also a paper that is from 2021 that uses this experimental data to validate its CFD model, and the geometry that is trying to replicate is this one. So basically it's a stepped spillway with an inlet and an outlet and the different boundaries. Okay, so we start using the CAD software. Let me open AutoCAD. A new document. You don't need to use AutoCAD, but make sure that in your export options you are able to export as STL lithography in this format. Okay. Okay, let's get to it. As you can see, this geometry is very simple. We can use a 2D slide and then extrude it. So we're going to do this. Maybe this part is going to take a lot of time, but you can skip to the part you're interested. So let's start going. Let's put this side by side. Okay. So we have 1 meter, 2.8. Plus this, make this a little bit more. Okay, and then we have 2.8 and 1.2. Okay, we have here 1.6 meters, and this would be 5, like that. This would be our bounding box. So let me find this height. Let me find that height, please. So we're going to take the height and the length of the steps. In this case we have a height of 0.1 meter. So we draw that starting from here, 0.1 and 0.2. We copy that, and I think there are 10 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we have an L crest of 1 meter. 1 meter. So we are there. We're using this flat step case. We're not using the pull steps. So we are missing this height. I don't think it's that important. So we take, maybe this one is 1 meter. Let me see. 9, 2, 3, 4. The fourth step. 1, 2, 3, 4. Like that. Maybe like that. Okay. So this would be our geometry. So there are parts here that we don't need, like this one, and this one. So this is going to be our CFD domain. Okay, fluid region, viewer. Okay, so now we have, these are separate lines, so we use join to merge them together, and we have our geometry here. So we're going to extrude this along the z-axis. So we extrude. Okay. If we don't see this, you go to the 3D basics, and you have extrude. If you can type extrude, and we make an extrusion of 0.52 meters. Let me set the units just in case. 2 meters. Okay. Let me check if this is still 0.52. Okay, we have now our solid. We're going to export this. We export this, export other formats. Let's work on our desktop. So we create a new folder, and we call this 3D mesh. Okay, 3D mesh, and we call this AutoCAD STL. AutoCAD STL. CAD STL, and we save that. So this is the first part in the CAD software. So we close this. We save changes just in case. Stop, 3D mesh, and this is the CAD-drawing. Okay, so we have this new folder. We made a mistake. We didn't export the STL, so I missed a step. So again, export other formats, CAD-STL save, and we need to select the solid and hit enter. And now in the folder we have CAD.stl. That is what we are going to use. Okay, we don't save. Now we are going to use Blender. Don't worry, that is a free software. If you don't have it already, you can search for Blender on Google, hit on download, and download Blender, the last version. If you are working on Linux or Mac, you can still do it. So you can download Blender for Windows, Mac or Linux. Okay, the installation process is pretty simple. You just read you just click next. Okay, so after that, after you have installed Blender, we open that, and here we choose general, and these elements here we drag our mouse, we select them all, and we delete them with the delete key. So now we want to import our STL. So find import STL, we search the STL we created, CAD.stl. Make sure that Y forward is selected and Z up. Okay, import STL. Oh, we made a mistake. We want this to start at the origin. So we do that fast. We open the CAD. Let me delete this, delete. We open our CAD. We are here. We create a line at 0,0 to have a point of reference. So we have this like this, make this extension, make this extension, okay, and this dot is going to be our reference point to move this from here to here. And now we delete these lines that are not needed, and now it's in the starting at the origin. If you're working with AutoCAD, make sure that you're always working on the positive side of this coordinate system. Okay, we export that again fast. Other formats, we override that. Yes, we want to replace. Select the solid and enter. We close this and we save the changes. Now we're back to Blender. We go to File, Import, STL, CAD-STL, Y forward, C up, and import STL. Okay, now we're ready. In this part, we hit the Tab key to enter edit mode. So we're in edit mode. Ahora, now we hit here. We align our view to this 3 axis, and we select the select mode, face select. We drag and select these ones, these faces, the side faces. We rotate, hitting the wheel button. We rotate and we align this to the C axis, and we select the other faces. So now that we have selected these sides, we hit the P key and then selection. So we rename that new layer. Once we do that, what we have done is separate those faces from the original STL. So we are going to call that layer sidewalls, and if we turn that layer off, we can see that we no longer have those faces. So now we are going to work with the inlet. So to do that, as we can see, let me open our AutoCAD file so we can have an idea of the dimensions. So here we have well, the drafting and annotations. We have 1.1 meters, and here we have 25 meters. So the inlet is this one, so the flow is going this way, in this direction. So we're going to have an inlet of maybe 0.6 meters. What is it? So that one is going to be our inlet. So we are going to differentiate that inlet from that other face. And so how we do that? First, we position ourselves so we can see the inlet. As we can see, there are 2 faces. First, we select them both, hitting one and then shift, and hitting the left click on the other. We right click and we select dissolve faces. So it's only one face now. So we go back to this and we select mode, edge select, and we are going to select these edges. This one, hold shift and select the other one. We are going to subdivide this face according to along those edges. So we hit right click and subdivide. In the bottom part we can see that this merges. We hit there. So we had 1.1. So we're going to make, let's say, 10 cuts 10 cuts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 new faces. Each one has a height of that would be 0.1 meter. So we want an inlet of 0.6 meters. So we go back to this face select mode and we select the 6 first faces. 1, shift 2, 3, 4, 5, 6. We hit P selection, and now we have another layer that we are going to call inlet. As you can see, we turn that off. Okay, we are ready with the inlet. So now we can call this. We're okay. We are once again in face select. We select these faces and we hit P selection, and those are going to be our atmosphere faces. We turn them off and we proceed with our outlet. Those ones, select those two, F9, cancel P selection, and we rename that layer outlet. Turn that off. Okay, and now I always like to make this differentiation in the bottom layer, because the phenomenon, the flow is going to be more complex in this case, in these phases, than in this one, because basically because of velocity. So we're going to need to have the finer mesh in this area. So we're going to first select these ones, and we're going to call selection. Let's call this wall 1, and the rest we can hit A to select all visible faces, and P selection, and let's call this bottom. Okay, bottom. We turn that off and we are left with nothing. So our original CAD-STL is empty, so we don't need that anymore. We delete that and we check. For example, we have wall 1, we have outlet, we have inlet, we have bottom, and we have our atmosphere, and finally our sidewalls, and that will be our computational domain. So we need to take this STL and export it in a way that OpenFOAM can read these names, because these names are going to be our patches, our boundaries. So I suggest you go to your navigator and search for this plugin, Rio STL, and in Reologic.net enter to the first option, and once we are here we download the STL. It's very light, so this is going to be our download folder, but taking in mind that we need to take this to another folder. Okay, so for example, we take this and place it in Rio STL. I have it here already, so I delete this one. Why is that? Because as you can see, we're going to try to use that plugin. So we go to Edit, Preferences, and here in Add-ons we hit Install, and we're going to search for that plugin. If we go to the download folder, it's showing. Sometimes it doesn't work, but well, that would be a tip then, to move it to the Documents folder or to any other folder. It works anyway. So we install that add-on. I already have it installed, so I'm not going to click here. Just hit escape. After you have installed it, just search for Rio STL, and this is going to be probably for you unchecked. So you check that, you mark that, and you're ready to go. So now we have a new option to export this type of files. That is going to be in File, Export, and ReOSTL. If you don't see that, just close your Blender and open it again, and it's going to show, I assure you. So we go there, ReOSTL, and we go to our folder. Let's go to 3D Mesh. I'm going to create a new folder. I'm going to call this Blender. You don't need to specify the name, you just need to uncheck this, no selection only, because we're going to export everything. We don't need to use prefix, ASCII, apply modifiers, it doesn't matter because we didn't use any. So forward as always, Y forward and phi up, and we export STL. So we go to our folder and we can see that we have 6 different files, one for every boundary that we have created. So we save them as ASCII, so it's readable. As you can see, here is the name of that patch, atmosphere, the same name as the title. So this is the Blender part. So now we can go. We are going to work with the block mesh utility.